Hey everybody, Miguel here. Today I want to show you how you can take an OpenAPI description that represents a REST API and very easily convert it into an MCP server, or rather an API proxy that you can deploy to Apigee, which behaves as if it was an MCP server. I like to call this process MCPifying a REST API. So how does this work? It's not that complex. You bring an OpenAPI description, then you take a template that I have created for you and I have put it in the examples directory for the apigee-go-gen tool. Then you render this template providing the OpenAPI description as input, and out comes a proxy bundle that you can go ahead and deploy to Apigee. Once this is deployed, you can treat it as if it was a regular MCP server. So let's go ahead and try it out. I want to demo this to you. So I have created a set of steps that I'm going to follow in this demo so you can see how this process works. So I have this OpenAPI description for a weather service. And you can see in here, this is a official, United States government weather API that you can actually go ahead and try it on your own. And what we're going to do is we're going to take this OpenAPI description and we're going to generate a MCP API proxy. We're going to deploy it to Apigee, and then we're going to try it out. And when we try it out, we're going to try it out with the MCP Inspector, and we're even going to use the Gemini CLI to test it. So let's go ahead and get started. So a quick review. So this OpenAPI description that I have is very long. It has over 100 individual operations that are available in this weather API. It has no authentication, no authorization. It's fully open. And we're going to try to fix that in Apigee. So first thing we do is we're going to generate the MCP proxy from the OpenAPI description. So here's the command that you run. Basically, you say apigee-go-gen render API proxy, and you pass in the template that has the information for how to transform the OpenAPI description into an MCP server. So here's the template. I'm passing in a remote URL in here. Or this could also be a file locally on your laptop. It's easier for me if I just pass a remote URL. That way I don't have to clone the repo. But if you want to make changes to the template, you're more than welcome to clone the repo and adjust the template to fit your business needs. So the other input is the actual spec itself, right? So we have the template and the OpenAPI description that we're going to use. We're also saying the base path for the generated MCP server or MCP proxy is going to be /MCP/weather. And finally, the output is just the proxy bundle that we're going to deploy to Apigee. All right, so let's run this. And you can see here that I run it and then the output already got created. So we have the proxy bundle. Next, we're going to deploy this proxy bundle to my Apigee organization. You can see the input is the proxy bundle that we just generated, and it's going to create a new proxy called MCP-weather. So let's go ahead and run this. So it's getting deployed. It got created and it's getting deployed right now. So we can go ahead and jump over to the Apigee UI in the Google Cloud Console to take a look at that. So I'm gonna go ahead and refresh this, and we should see that the new proxy is there now. Just now it got created, and it should be getting deployed. So it will take about a minute or so before it gets deployed. So while that is deploying, I'll give you a quick peek behind the scenes of what is inside this proxy. So if we go to the Develop tab, you can see that the operations that are in here are basically the operations that define the MCP protocol itself. And under the hood, this proxy is doing the transcoding operation. So when an API, or rather when an MCP JSON RPC call comes in, it will take that JSON RPC payload, inspect it, and transform it into the proper REST API payload that is needed for the API that is going to be called behind the scenes, which is the weather API in this case. So looks like it's deployed. So we can go ahead and try it out now. All right, so how are we going to test it? There is something called the MCP Inspector. This is a developer tool that it's actually the official developer tool for testing MCP servers. So I'm just going to run it and pass it and point it to the MCP proxy that we just deployed. So let's go ahead and run this. And you can see now that it opened up and the URL is pointing to my MCP server. And before I actually connect to it, let me go ahead and start a debug session in Apigee so we can take a look at what's happening under the hood when we actually start interacting with it. All right, so it looks like it's all good. Let's go ahead and connect. And voila, we're connected to it. So this MCP server, right? We can call it a server because from the point of view of the inspector, it doesn't know that it's just a proxy in Apigee that's a transcoder that points to a REST API. The MCP inspector has no idea. MCP inspector thinks this is a proper MCP server. We can go and click on tools and then we say list tools. And basically these are all the individual operations that came from the OpenAPI description. And like I said, there's a lot of them in here. And I'm going to try a couple of them so you can see that it actually works, that it's actually passing through the data. So let's try checking alerts query. So we can do, I want to see alerts in the Pacific. So this is just a code that means Pacific. And let's go ahead and run the tool. And you can see it was a success. And here's the actual response that came back from the government weather API. And we can just take a look at some of those responses. Looks like there was a weather alert. It's a submarine weather alert that's happening in here. A small craft advisory weather alert. You can see it's actual data that's coming live from the backend REST API. So, so where all this come from in here, right? You can see there's a lot of stuff that can enter in here. So one of those things was just the area. So this information that you see in here when you're making the MCP tool call came from several places. One of those places was from the the parameters that are defined for that operation. If it's got query parameters, form parameters, those type of things, they will end up in here. The other thing that will end up in here is if it's a post operation behind the scenes, the request body that is needed for that post operation will also end up in here in this form. All right, so let's see how what actually happened behind the scenes when I did this this tool call. So let's see in the debug, we should see a few operations show up in here. So initially, like the first operation should be, let's see, request. It was supposed to initialize. So this is just part of the MCP protocol. You can see it's supposed to the MCP server with the JSON RPC method for initialization. And there's a few other operations in between that just part of the initial handshake protocol. But the last call itself was the actual tool call. And you can see here the actual tool call was, you can see MCP tool call, and it was alert query, and that was the parameter that I passed. And what actually gets sent to the backend, it's not JSON RPC, obviously, because it's a REST API on the back. And you can see it's a get to /alerts, and then the query parameter is passed in. So there's a whole translation that is happening from the client, who is a MCP inspector, sending a JSON RPC call, and then internally we do the transcoding to convert it to a REST API call, and finally that gets sent to the target. And this transcoding operation is actually pretty efficient. You can see it's done in JavaScript, but it only took 3 milliseconds for the main transcoding operation. The bulk of the actual time of the request was just spent on the target. The time in Apigee was pretty small. All right, so let's move on now. So we tested it from the MCP Inspector. Next, I want to show it to you being tested using Gemini CLI, which I think is pretty cool. So if you haven't tried Gemini CLI, I highly recommend you try it. And it's very easy to use MCP servers with Gemini CLI. You just have to edit the settings JSON file in Gemini CLI and point it to your remote MCP server. There's a few more settings you can put in, but this is the bare minimum that you need. So let's go ahead and copy this and edit my settings file. So we have it right here. All right, and I'll paste the settings. So now Gemini CLI is aware of my MCP server, and if I go and run the Gemini CLI, we should be able to actually talk to the MCP server in natural language, which is pretty cool. All right, so Gemini CLI is open. We can do /MCP list, and you look at that. It loaded my full MCP server with all the tools that are there. Now, this is not great though, because you don't want to give so many tools to an agent or to an LLM, because they can get confused when they have so many tools available. So typically you want to filter and only show the LLM the tools that you need for whatever you're doing at that moment. We'll fix that in a little bit, but for now, let's just leave it like this, and let's ask a question. Let's say weather alerts in California. And hopefully it will see that it has an MCP server for weather alerts and show me the weather alerts. Great, so it detected, hey, I have an MCP server called Weather Remote. So I'm gonna say, yes, please allow all tools from Weather Remote. Go ahead and call them. So it's making the actual tool calls and getting the response and processing the response before it actually shows me a natural language response of the weather alerts. All right, so let's see what we have in here. Yeah, so this is the same, basically the same call we did manually. And there you go. You can see there's some weather alerts. Looks like some in Los Angeles and some in Yosemite and San Francisco. So yeah, this is actual live data that came through that MCP server. Isn't this really cool? I mean, I love this. All right, so let's move on. So we tried it from MCP Inspector. We tried it from Gemini CLI. How about we try actually doing tool filtering? So I remember what I said, that those list of tools, that's too much for an LLM. Like you usually just want to narrow it down to just a set of tools that are needed. The server that the MCP proxy that gets generated has a capability where you can pass a header. The client itself passes a header and say, hey, I only want to see these operations or these tools in the response. So when the MCP server makes a tools list call, when the MCP client makes a tools list call, the API proxy in Apigee will filter the response and only show those tools. So let's go ahead and try this out. So if we go, let me go ahead and kill the Gemini CLI. So if we go back to the inspector, and we can try setting this header over here. So let's go over to the inspector. And we can do, I think, under authentication, have some stuff in here. It's not needed yet. So headers. Oh yeah, we can add a header. And this is the header, XMCP tools filter. And the value says, hey, I just want to see only these two. All right, let's set it in here. And let's disconnect and reconnect. Now, if we do tools list again, let's clear the previous list, and we see only the tools that we put in the filter. And similarly, we can try the same stuff in the Gemini CLI. So I can go to the settings JSON for Gemini CLI, and in here we can say, pass this header also when you're interacting with this MCP server. So if we go over back to and rerun the Gemini CLI, all right, so, and now we should be able to do MCP list again. And there you go, only those two tools are showing. So that's the other capability that I was referring to earlier, right? So, we have over 100 operations in the API proxy, but using tool filtering, which we're just showing two. What about authentication and authorization? We're gonna come to that next. All right, where were we? Tool filtering. So I just showed you tool filtering. Let's go to governance with Apigee. So what is governance? So there's two things in here, right? So you have authentication and authorization. Those are two separate things. So when you create when you convert the OpenAPI description into a proxy bundle, I have in here in the template included two options that you can pass. You can say check for app authentication and also check for app authorization. And that has two different meanings. When you do check for app authentication, that means that inside the API proxy, there's now going to be a verify API key policy that's going to basically require you to pass an API key when you call the API proxy. Now, the check for app authorization, what it will do is that it will check that obviously that the app is authorized to access the the proxy that you're calling, by making sure that it's part of a product, and also that inside that product that you have a list of tools that you're allowed to call when you call this MCP server. So it will make more sense in a little bit. So let's go ahead and recreate the API proxy, the bundle, and let's go and so once it's created, let's go and redeploy it. All right, let's go over to Apigee. So let's go to APIs back in here. Actually, no, that's the API hub. Here, just redeploy it now. If we look at the develop tab, we should see now that there's an API key policy validation in here, right? And there's also an extra step that's going to check for authorization, and it's a product-based authorization. So what do I mean by that? So obviously API key validation is very simple. Do you have an API key that exists in Apigee, yes or no, right? And then the product authorization is slightly different. So I already have an app created, and I also have a product. So let's go ahead and take a look at it. So this API product I have created ahead of time. It has my MCP server listed as one of the proxies that's available to use. But that's meaningless, because an MCP server is just an endpoint. What really matters is the operations that you're allowed to make on that MCP server, or the tools, right? The tools are allowed to call on that MCP server. And for now, I'm specifying this as a custom attribute in the product. I'm saying, hey, these are the MCP tools that you can call when you have an API key that's allowed to call into this product. Right now, I have it set to a wildcard, which means allow all the tool calls that are there. But I could edit it and basically only allow a subset of the operations in there. So I could say, hey, instead of this, I will allow tool 1, tool 2, etc. Right? And what this means that when somebody comes with an API key, even though they have a valid authentication, they may not be authorized to call a certain tool unless that tool is listed in here in the MCP tools. Now, this is a temporary thing using a custom attribute. Eventually, in Apigee, there will be a first class capability where you could list JSON RPC operations as part of an API product. But in the meantime, I'm making use of a custom attribute to represent the same thing. All right, cool. So let's try it out. So I think the API should be already deployed. Actually, let me show you the app as well. So I already have the app that I created earlier, and I'm calling it the MCP Weather app. And this app is subscribed to that product that we just saw. And I have the API key here as well. And I already got it copied in my text editor, so I don't have to copy it from here. But let's go back to API proxies, and let's do a debug on the MCP Weather. So it looks like revision 2 is already being deployed, which is great. All right, so while it's debugging, let's make some calls from the inspector, and we should see that there should be an error if we try to actually call something. So let's say alerts query, because I don't have an API key specified at all in here. So if we try to do the same call, let's see, run tool, and there you go, an error, failed to resolve API key, and saying, hey, you have to pass an API key. So how do we do that? It's pretty easy. We just come in the inspector, and we say, all right, sure, let's pass, X API key, which is the header that it's asking for, and I already have the value for that over here. So that's my X API key for that app that I showed you earlier, and here it is. Now, I think I had to disconnect and reconnect to make this work. I cannot just set it in here, so I'm going to reconnect. Now let's do tools list again. Tools list still works. And let's just run the same call now. And we'll run the tool. It's taking a little bit longer now, so I'm not sure why, but still an error, request timed out. Not sure what happened there. Let's try rerunning it. Oh, there we go. I guess there was a glitch in the matrix there. So there you go. You can see the calls are actually working now, and we should see some of those calls now happening here. Interestingly, okay, so one of those calls took really long. That's why we saw, you can see 10 seconds in here. That's why we saw that timeout error in the MCP Inspector. This is a trial organization. You can see here, right? This is not a production organization. If you're actually running this in an Apigee production organization, the timing will be much more consistent, right? So don't worry about that. So let's see the actual call. You can see the initial call we made for that we didn't where we didn't have an API key. It errored out with the verify API key validation policy there, right? So that was expected. Then the last call that we made, let's take a look. The alerts query, and we passed the proper API key at that point, and that worked too. So it's working. Now we have authentication with API key plus authorization, which is done in JavaScript. But again, this is a temporary thing. Later, Apigee will have support for first-class authorization using a new type of operation that's going to be defined at the product level. All right. I'm not going to go and change the product to allow a different set of operations, because that takes some time, like a couple of, maybe like a minute or so before the changes take effect. But the support is there. If you go in the product and you say, hey, here's a different set of tools, this authorization policy is going to check and make sure that the tool that is being called at that point is listed as part of the product in that custom attribute. Let's try this also from Gemini CLI. I'll show you how you can do the same thing in Gemini CLI. You basically, it's almost the same process. You go to your settings file and you add, here's another header that Gemini CLI should pass when it interacts with the MCP server. So let's go ahead and rerun Gemini CLI. and it should still work because now we're providing an API key. All right, so no errors, nothing. If we do MCP list, it's still there. So, and it's green, that means it actually did the initial handshake and it's all good. All right, so I have showed you basically, tool filtering, authentication, and I show you how to do authorization. I didn't actually demo the authorization part, but trust me, it is there and it works. You're more than welcome to try it out. What if, and this was just for authenticating and authorizing the app itself. I mean, we're not talking about authenticating or authorizing the end user, but let's pretend that we have an API that's protected by OAuth, right? And we want to be able to support that with this auto-generated MCP server. How does that work? So I have already done this ahead of time, and I have created another version of the OpenAPI description that basically has a security requirement defined that says, hey, this entire API is protected by OAuth. And I'll show you here. I'll do the diff so you can see it. So you can see the only difference between left-hand side is the whether that YAML that we were using, and the right-hand side is the new one that we're going to use next, which has a security requirement that says, hey, this is protected by OAuth, OpenID Connect, and I'm giving the OpenID Connect URL, which it's a basically a trial that I have in Auth 0. So let's go ahead and try it out. So what's going to happen differently now? So let's go down to my demo steps. So the generation of the proxy bundle, it's almost the same, like nothing changing here, but now I'm passing the new file because this file has the OAuth security requirement defined in there. So when it gets generated, now the proxy will have a few extra things in there. One of those things is called a protected resource metadata endpoint, which is something that MCP requires MCP servers to implement so that the clients are able to discover metadata about the auth authorization server that is used to protect the MCP server. You can go ahead and read more on this in the MCP spec. So basically, it's the discovery mechanism that clients will use to interact with the MCP server and know how to get a token, basically. And actually, you know what? I'll demo it to you because the MCP Inspector has a very cool wizard that shows you step by step what it's doing. So we'll try it out. So first, let's go ahead and deploy or recreate the proxy bundle from the new spec. All right, so we are recreating it. Now let's go ahead and redeploy it. All right, so let's go ahead and take a look in Apigee API proxies, MCP weather. You can see revision 3 is being deployed right now. Now, so what is different? It's not like I dropped an OAuth verification policy in here. You could do that if you modify the template to do that. The verify API key is still happening. But the main thing that's different in here is we have this extra proxy endpoint, which is called a protected resource metadata. And like I said, this is part of the MCP spec where it requires MCP servers to implement this. And the protected resource metadata is actually quite simple. It's just returning a JSON document that contains the address of the OAuth authorization server. And this is for MCP clients to be able to do stuff like dynamic client registration and discover what scopes are supported, those type of things. So let's see, is it deployed yet? Okay, it's deployed. Let's go ahead and do a debug. And let's start. So let's test it with the MCP Inspector. So if we go to MCP Inspector, now let's disconnect from this. Actually, let's kill it completely, just so that you can see the experience. So let me kill this tab and go to my MCP Inspector. Should be one of these tabs. I'm just going to close all of them. Let's rerun the MCP Inspector. And look at that. So MCP Inspector opened, and now we're going to try to connect. If we try to connect, let's see what's happening. Oh, it prompted me for OAuth authorization. So all the discovery and all the OAuth flow happening behind the scenes is working as expected. Now I can do accept, and I am connected. So the API key validation is still happening. It's just now that because we had that protected resource metadata endpoint in there, the MCP client knows that this MCP server is protected by OAuth, so it needs to do the OAuth dance before it actually connects, so that every time it calls a tool, it sends the OAuth bearer token. So the other stuff still works, listing tools, that's all good. But remember I mentioned that the MCP Inspector has a very good wizard that shows you how all this OAuth stuff works. Let's go ahead and try that. So let me go ahead, let me disconnect, and then we're gonna do, this OAuth wizard that they have, and we're doing a guided OAuth flow. So the very first thing that's gonna happen is metadata discovery, and you can see it's successful. And you can what came back in here, it's it went and hit my actual API proxy, although this is not actually quite right. It didn't hit this. It hit the proxy endpoint within the proxy. So we should see it in here. Let's see. Yeah, this is the actual call when it did the discovery. And you should be able to see this was the base path, well-known OAuth protected resource /MCP/weather, which is not what they're showing here. So I guess that's a bug in the MCP Inspector, but they are showing the correct response, which is what the proxy is responding with. So once MCP Inspector gets this, basically they go and probe this authorization server to get the actual authorization server metadata, right? So they go and visit that URL, get more information. That's not involving Apigee. It could involve Apigee if you had a auth facade that goes through Apigee, but this is going straight to auth 0. Next is going to do client registration, and basically because auth 0 supports dynamic client registration, it went ahead and registered. And don't worry about my client secret showing in here. I'm going to be deleting this client secret and all these tokens immediately after this recording, so it's fine. And next, preparing the authorization. This is the initial step. So all of this was just to get to the first step in the OAuth dance, which is go to the authorization endpoint and basically ask the user for consent, right? Which is this. So I accept. Now we get the authorization code, and that came from auth 0. Put it in here. Continue. Finally, the MCP Inspector is going to exchange this authorization code for a token, and the authorization is complete. How cool is this? I mean, I love this little flow that is showing you everything, because if you're not familiar with OAuth, this is pretty good to see, so that you get a grasp of what's going on behind the scenes. And now that we have a token, we connect, and that's basically it. Let's do a tool call. So clear tools, list tools, and let's do the same tool call that we've been doing. Run tool. And there you go, it's successful. Now let's take a look in the debugger. We still have 5 minutes left. That's great. So, and there's other calls that are happening here for cores, like options and stuff like that, because the MCP Inspector is running in a browser tab, right? The browser is making sure that it can call to a service that's sitting somewhere else. But the call that we actually just made is this one. Once again, this is, wait, is it this one? Might be a different one. Oh, that was the tools list. Oh, my debug session ended right before I make the that call. You can see, I thought I had 5 minutes left. Let's start a new debug session. Okay, so let's go back, start a new debug session. And let's just repeat that call. I just want to show you that the token is it's gotta be in there somewhere, right? So let's run the tool call a couple of times. And hopefully we should see something in here. Oh, there we go. Post. There it is. Tool call for alerts query. And in the request headers, there you go. See authorization. And that's that bearer token that came from that OAuth dance. It's in there. Now, I'm not actually verifying the bearer token, right? I'm just doing verify API key. And the bearer token is actually just being passed through down to the target, in which case this target doesn't care about the bearer token either because it's unprotected, but you get the idea, right? Now, you could have other policies in here, like instead of the verify API key policy, you could have the OAuth verification policy. Right, so you remove that one, put the OAuth verification policy, and maybe once OAuth verification succeeds, then there will be a claim in there somewhere in the token that lets you figure out which app is the one calling so that the rest of the authorization can proceed. All right, so I think we're almost done. So we just tested it with the MCP Inspector. Actually, one last thing. Let's test it with Gemini CLI. So we're not making any changes. It's still the same configuration in here. HTTP URL, the API key, the tools filter, but we're just gonna run Gemini CLI and see what happens. And let's go over to here. Gemini CLI, let's run it. All right, so it says error, authorization failed, MCP auth. Okay, I need to authenticate. Let's try that. MCP auth. Oh, where did my MCP? Let's try it out. MCP list. Oh, I need to tell it MCP auth whether remote. And there we go. So it opened up the the consent screen. So I accept. There we go. Gemini CLI got the the token that it needed. And if we do, you can see here, it told me, hey, successfully authenticated for MCP remote. Gemini CLI, sometimes it just automatically, when it opens up the OAuth consent screen, now it wanted me to explicitly authenticate, so I had to run MCP auth whether remote. But it's working. MCP list, now it's connected, and there you go. That's all I have to show you. And this being a long video, but I hope it's worth it. And if you're trying MCP, please try this out. Like if you have APIs that are out there, in your organization that are REST APIs, and you want to enable an agent to use those APIs, you don't have to go and create a new Git repo and generate a fast MCP MCP server, deploy it to Cloud Run, nothing like that. Literally, you just take the OpenAPI description, generate the proxy bundle, deploy it, and you have an MCP server that's ready to go. And that's it for this video. So if you have any questions, jump over to the Apigee community. I'm over there. Send me just post a question, and I'll be monitoring and answer your questions. And this is all. My name is Miguel Mendoza, and I hope you learned something new today.